I'm just going to give you a quick tutorial on how to work with compound interest if you've never done this before. Compound interest is a way that a lot of banks will calculate the interest that you've accrued on money you've left with them. The difference between compound interest and simple interest, which we talked about earlier this year, is in compound interest, your money keeps increasing by a certain percent every year. So, for example, if you invest $4,000 at 8% per annum means per year. So every year you're going to earn 8% on your $4,000. What that means then is, initially, you're going to start with your $4,000. After 1 year, that amount is going to be multiplied by 1.08. Remember from yesterday, this is 100%, this is the original amount you had. And then the 0.08, this is the 8% increase. Okay, so 1.08 means 100 plus the 8% increase. So after 1 year, multiply by 1.08 and you'll get 4,320. After 2 years, you would take that 4,320 and multiply that again by 1.08 because you're earning another 8%. But remember that 4,320 is the same as 4,000 times 1.08, which we saw already up here in the first part. So really, we're going to take that 4,000 times 1.08 and multiply it by another 1.08, which is the same as saying 4,000 times 1.08 squared, or $4,665.60. Now, if I was going to year 3, I'd multiply that by another 1.08, but notice that would just change this because I'm going to multiply it by one more 1.08. So after 3 years, it would be 1.08 cubed, and so on and so forth, where we can then say after n years, the value of this would be 4,000, which is my initial investment, times 1.08. Remember the 08, this is the compound interest. It's 1.08 again because it's an increase going up, and then n, this is the number of years. So any amount we want, then we can say the initial investment times 1 plus whatever the compound interest is, written as a decimal, to the power of the number of years. 4,000 times 1.08 to the power of n. So let's try that with something. So let's say I invest 70,000 Chilean pesos at $6,000 interest, and I'm going to compound this annually again, so every year I'll earn another 6% on this. So I want to know first, how much would I have after 10 years? Well, what that means then is I want to find A of 10, the amount I have after 10 years, and I'm going to just take my initial amount again, so 70,000 times 1 point, and in this case, because it's 6%, it's going to be 1.06 to the power of the number of years, which is 10. And from here, it's just a little calculation. 70,000 times 1.06 to the power of 10, and that's it. So after 10 years, if I leave my money in the bank at 6%, I will have changed my 70,000 pesos into 125,359, more or less. Just by doing nothing but leaving it in the bank. Okay? Another question you might say, well, how about how long will it take to reach a certain value? So let's say I want to know how long will it take until my 70,000 pesos turns into 7 million pesos. So it gets multiplied by a factor of 100. Right? What that really means then is I want to solve this equation, 70,000 times 1.06 to the power of n, because I want to know after how many years, after n years, equals 7 million. And this becomes a problem like you were working on yesterday. And you can do this a couple ways. If I wanted to, I could divide both sides by 70,000. And I would end up with 1.06 to the n equals 100. Okay, and then I can use my calculator to do that. I probably should have done that, but instead I just put them in as they are. So instead I solve this by just entering these two things in my calculator. So on one side, in y1, I entered the right part here, 7 million. And it doesn't matter, you could enter this in y1 or y2. On the other side, I entered 70,000 times 1.06 to the power of x. Right? Now the one thing you need to be careful about here, these are big numbers, so you need to make sure your window fits. So for me, I went from an x min of 0 up to 100, meaning I'm assuming it's going to happen in the first 100 years at some point, and my scale is going to be 10 because 100 is a big number. My y min, I'm going to go something below the y-axis just so I can see it, up to 8 million because that's a little above 7 million, and I'm going to go by steps of 1 million on my calculator just because, again, that's a big step. All right? And then I can take a look at the graph, and I can see this. So I can see this line here, which is the 7 million line, and then I can see the line coming up here, which is the line y equals 70,000 times 1.06 to the power of x. And I'm interested in this point right here. All right? So this is where we're going to use the calculator. Remember second calc and then intercept. I'm going to erase this. And again, it's going to ask for a first curve, a second curve, and a guess. So just be sure you choose the two curves. First curve, I'm going to choose one of the two. Second curve, I'm going to choose the other one. And then the guess, make it kind of close to where you'll be. Hit enter, and there's your answer. Again, because I'm solving for n or x in this problem, that means I'm interested in only the x coordinate for a solution. So in the end, my answer is going to be n is 79.0 years to 3 significant figures. Okay? So what that means is it will take about 79 years for me to get from 70,000 to 7 million Chilean pesos if I do nothing but leave it in the bank at 6% interest. Okay, that's it. I think you can do the rest on your own. I'm going to put a worksheet up with 4 problems. Number 4 is going to be a comparison. You're going to use compound interest, but you're also going to use something else. So you're going to have to also, for number 4, think about the fact that if I was going to triple $10 every year for n years, I could find that equation using this function here, which would be 10. This is my initial amount again, times 3 to the power of n. And 3, this is because I'm tripling. I think I spelled that wrong. Tripling every year. So every year I'll multiply it by another 3. All right? So 10 times 3 to the n, and that'll give me how much I have after n years. You're going to have a problem similar to that tonight to work on. All right? So good luck, and again, email me if you have questions.